This is a Graco PR70. It is configured for an H.B. Fuller UR2159. Two-component urethane wood filler. It's an air-powered machine with positive ratio pistons. That's set for a 3:1 by volume. This is a demo machine, so your machine may look a little bit different. But what you see right here is a standard base machine with an air-powered piston. The metering pumps are in this area. There's also a hydro check, which I'll go over a little bit later, which is very important to slow down the dispense in this application. We have 8-liter polyethylene tanks. This one is equipped with agitators on both sides. That's not going to be a standard. This is just the demo machine. Agitators are not necessary with this product. You'll have a display module. It'll be slightly different than this. And then this is the MD2 gun with a static mixer. For demo purposes, we're using a standard static mixer. I'll go over some of the other mixer designs, and we'll have a configuration and a suggestion for what types of mixers you should use in this application. Your system will come fully assembled and calibrated with no material in the tanks. What I'm going to talk about now is in brief, and I recommend going to the Graco manual for full instructions. But essentially what we're going to have you do is fill up the tanks, and we need you to bleed out the hoses. In order to bleed out the hoses, on low viscosity materials, you're going to want to take that hose and make sure there's no low spots and extend the hose in this effect, and basically you're just going to pump material until it starts coming out of the gun. We don't want any high spots or low spots, because that's where air bubbles tend to travel, and if there's air bubbles that are in the machine, then you can be off ratio. So you're going to want to fill the machine, make sure that all the air bubbles are out of the hose, and you're ready to go. Now that you've purged all the air out of your hose, you're ready to fill your static mixer. Put a new static mixer on. I like to have pliers with me to cinch down on that retaining nut so there's no leaks at the nut. Take a couple of shots into a waste container. Make sure you got good mixed material coming out, and now we're ready to start dispensing. Now we're ready to dispense. I simply pull and hold the trigger. I have the hydro check set at a very high level right now. These are just very small shots. I'm going to turn my hydro check, and now you'll notice a much slower rate of dispense. I'm going to adjust it a little bit more. And show you the difference. Now I've let the static mixer sit for about 1.5 to 2 minutes, and I'll show you what it looks like. I pull the trigger. Nothing comes out. That means I let it cure too long in the hose. So what I need to do is put my safety on. So the material has cured up in the hose. I take the retaining nut off. I take the old static mixer off. I clean up the tip, and as you can see, the two materials don't start mixing until it comes into the gun. So I'm okay to put a new static mixer on. The retaining nut. Take my safety off, refilling a new static mixer. And I'm ready to start going again. So at the end of the day, shutdown procedure is turn the air and electric off on the machine. We'll refer to the Graco manual for that. On the gun side, you remove your retaining nut, Take the old static mixer off and throw it away. Wipe off the tip. And what we want to make sure is that the A and the B sides do not cross-contaminate. So just clean out that a little bit. Take some grease, and I cover the holes pretty liberally. I like to have grease coming around, so when I do my retaining nut, I get some grease in those grooves, and that'll make it easier for me to take it off the next day. And then you're ready to go home for the day. This segment, we're going to talk a little bit about static mixers and the configuration that we used on this demo machine. Right here I have several static mixers laid out. This is the inside elements, just for reference. We're going to have a recommendation with H.B. Fuller as far as the number of elements, the diameter, and the length. You're going to be using something similar, more similar to this version. These are just other versions with wider diameters and different elements. The benefit of using a smaller one, especially with this material, is that it cures so fast that we don't want as much material in the tube. So a smaller diameter is going to be a better advantage to you. And then the minimum number of elements will be required to make sure you get a thorough mix. So these are just a couple examples. This is going to be more along the lines of what we're going to recommend. Now the samples in these cups are going to reflect what we can do with the demo machine. The demo machine is configured for larger shots, meaning the high volume size has a 960 metering tube and the low volume side has a 320 metering tube. We can use lots of configurations to get down to a lot smaller shots, but what I did here is this is similar to the shots you saw in the earlier scene where I was just tapping on the trigger. It comes out to about 2 grams. On the machine, there's shot settings, and you can program certain shot size based on the metering tubes. With the largest possible metering tubes, a 10-gram shot is the smallest shot that we can program, and a 65-gram shot is the largest shot that we can program. Obviously, we can go higher on the larger shot, but we can't go lower on programming another shot. And it's very important to distinguish between a calibrated shot versus just tapping on the trigger. There's not going to be any performance difference with your mixing or the quality. We're just not going to be able to program a shot smaller than 10. We'll have criteria for other metering tubes to get that 10-gram shot down lower. And that will be in with your literature.